Okay, welcome back. This is the last part of lecture 3. I'm going to briefly mention an application. I strongly recommend you to read this paper because it's a kind of a nice application of Lasso in empirical finance that could be useful for high frequency analysis of returns, high frequency prediction, and then can be used also for trading applications. Okay. So this is based on this paper by Alex Tinko and co-authors, which was published in 2019 in the Journal of Finance. So the idea here is that what the authors did, they take 1 minute returns for the whole universe of assets traded in the New York Stock Exchange. Okay? And their idea is to see if the next minute return can be predicted by the current and past returns of the firm and all the other firms. Okay? So they are using current and past returns for the whole universe of firms to predict the future return, the return for the next minute of a specific firm. Okay? So it's really high dimension. Okay? So what they show is that, and they are going to estimate this model by Lasso, and they show that Lasso increased both out of sample fit and forecast implied Sharpe ratios, and these out of sample success will come from identifying predictors that are unexpected, short-lived, and sparse. So once you identify a predictor, it's a good predictor for only a short period of time. They are going to do it like several moments over the day, and these predictors don't survive much. Okay, and they're going to provide some intuition about this is the case based on events, on news that these predictors will bring information about news, especially news about fundamentals. Okay? So that's the idea. They have like a window of 30 minutes, okay, as you see here, in this block here, okay. So they use these 30-minute windows, okay, to estimate coefficients, okay. They use the estimated coefficients to build a forecast for the next minute. Okay? So they have a 30-minute window, so they have like 30 time observations. Okay, so t equal to 30. Okay, they are going to consider a model of up 3 legs of all returns. But it's not of a single, it's not an AR3. They are looking for 3 legs for the whole universe of returns. So they have thousands of variables. So they have like P is the order of 10 to the power of 3. Okay? So it's really a large set of returns. So it's really high dimension, and the balance between number of variables and returns and time observations is like huge. So many more covariates than observations. Okay? And let's see, so this is really high. They are going to do it with Lasso, and in their paper they are selecting the penalty parameters of the Lasso using cross-validation. So first thing you should think about that we can discuss in our live session is that, is Lasso the best solution in this case? Which kind of, based on the theoretical results that we saw in this lecture, what you can say about using Lasso with this problem. Okay, think about it. Okay? I'm not going to give the answer here. We have to think about it, and we can discuss later. Okay? And basically what they show is that this is the out of sample fit of the lasso. And one thing that what they're going to show is the following. They are not going to present, they don't present the results for all the returns. So every window of 30 minutes, they're going to do this estimation. They random select 250 assets to present the results. They take the 250, they run these models for 250 assets. They produce the forecasts, and for the following 30 minutes, they do it again for 250 assets, okay? So this is the R squares, okay? The out of sample R squares over the years. So you see that the R squares are different from 0, okay? Around 2.5% R square is the average. So on average, Lasso 1 minute ahead return forecast explains 2.5% of the variation in the stock returns in a given day. Okay? So, and Lasso explains at least 1% of the variation of returns during every month in the sample. So you may think, well, 2.5% is too small. But for this kind of a problem, see, this is really high frequency forecast of returns. These numbers are huge. These numbers are pretty high. And then how this compare to benchmarks. So what you can see here is the increase in R squares as compared to a pure AR3 model. So we are not including any of the other cross-section returns. So it increased 1.8 in terms of R square percentage points. If you include just a market, so if you are regressing your returns on the high frequency market return, like the S&P 500 returns, you can increase your R squares in 2.5 percentage points. If we include AR3 and the market, you increase in 1.4. Okay? And if you try AR1, AR2, AR4, AR5, or an AR selected by BIC, all positive. All positive. Okay? Sorry about that. That was my phone speaking. Okay? So, now if you take like other factors, like market industry or market size value, so that's the typical Fama French stuff. Still positive gains. So basically this cross-section is helping to forecast the returns, and it's just not picking some well-known factors. It's something else. Okay? So the model is picking something else. And so is this stable over the sample? So they compare the out of sample fit with the market benchmark. So the picture on your left is like the monthly increase in R squares of the Lasso method with respect to the market benchmark and the AR3 benchmark. You see that there's positive increase in R squares over all the sample. Especially in the market benchmark, the increase is higher by in the second half of the sample, okay? As you can see here. And also, is this stable over the day? They say that when you see the picture here on the right-hand side, you see that the increase in R squares is more or less, it starts a little bit lower in the beginning of the day, but after 1 hour of trade, it stabilizes. Okay? So it seems it's a pretty robust result. Okay? And they also look in this table, for instance, okay, but if we, maybe this result is being driven by some specific firms. So let's look at firms ordered by market capitalization, volume, volatility, and spread. Looks at the firms over the median and below the median, okay? And you see here that the gains are significant if you look for high or low sets. And this is with respect to the AR3 benchmark. Okay? And of course, for firms below the median, in some cases the gains are higher for spread and volatility, but slower for volume and market capitalization, and then it works the other way around. But you see, these differences are significant. And if you go to the market benchmark, again, very high gains and all significant. So there's no evidence that the results are being driven by specific firms. Somehow uniform over firms, okay? And also, if you look at different sectors, there are many sectors here, you see that the increase in R squares are positive all over the sector. It's not being dominated by one specific sector, okay? And now, okay, can we somehow make money out of this? So let's look at Sharpe ratios, okay? And basically, we are looking at Sharpe ratios net of trading costs, okay? And we compare with a buy and hold strategy with S&P 500, the Lasso strategy to buy or to sell stocks based on the signal that the Lasso will give if the return will increase or decrease, and the AR3 model, the signal of the AR3 model. S&P have a Sharpe ratio of 0.12. The Lasso has a Sharpe ratio that's more than 10 times higher. See here, 10 times higher. And the AR3, so if we use just the signal from the firm, the pulse of the firm, we have negative Sharpe ratios. So we are losing money, okay? And if we take the Lasso implied strategy and look at the return, how these returns are related to other factors, you see that it's not, we have positive alphas, so meaning that we have gains, like non-trivial gains, and the explanation by the market is not barely significant here, but okay, there's a component that's given by the market, but you see the other Fama French factors, all non-significant, okay? So these gains are not explained by the exposures of standard risk factors like Fama French. So there's something else going on here, okay? And also, if you look at like trading frequencies, we see that Lasso makes less trades than the AR3 strategy, okay? But these trades can be highly successful, okay? And there's also the second table, you see some dispersion over different characteristics. But I think what's interesting is that the implied trades of the Lasso are kind of almost a half of the trades implied by the AR3 strategy. Okay? here's a kind of a table that shows that there is little correlation between the Lasso choice of predictors and firm size, trading volume, return volatility, and bid-ask spread. So basically say, okay, it's not picking like specific firms. It's nothing that basically it's not something that's because of an industry factor or again, that's to shed some light that it's not the usual risk exposure that's kicking in here. Okay? And they also report the estimated lambdas, and here they make a claim that the Lasso typically ignores all predictors weaker than lambda equals to 2.5% per month when making its 1 minute ahead forecast returns. Do you think this is correct? Remember the first block of lecture 3. Do you really think this is correct? Can we say that lambda is directly related to beta in general situations? Think about that. We are going to discuss this during our live session. Okay? And this is the predictor sparsity. So sparsity is stronger in the beginning of the sample and getting less, the model is less restrictive by the end of the sample. Okay? And this is kind of I think the nice, a nice picture, okay? You take news about a firm. This news can be scheduled or unscheduled, unanticipated news. Unanticipated news is on the plot on your right, and anticipated news, scheduled news is on the plot on your left, okay? So the vertical line, 0, is the moment the news is released, okay? So what you have like minutes before the news and minutes after the release of the news, okay? So what's the y-axis? It's the difference between the number of times that the Lasso select the N stock as a predictor when making its 1 ahead return forecast for minute H, and the number of times it did for minutes. So if you're picking a regressor, is there any change of the amount of times you select that regressor before the news, on top of the news, and after the news? So the structure of the selection mechanism of the Lasso changes. Okay? And the red dots denote differences that are statistically significant at 5% level. Okay? It's not clear how the author computes these significance levels. Is another point for discussion, but let's take it for granted. So basically, let's look at the plot on our right, on our left, sorry, schedule news. What you see is that what we see before and what we see after is not very different. The amount of significance is almost the same, and the frequency of selection is almost the same. Okay? Let's look at unscheduled news. Like 10 minutes before the news, the Lasso make a lot of changes in terms of which regressors it selects. And these are significant. And that's where the gains are coming from. When you have unanticipated news, somehow there is some information hidden in the cross-section of returns in the minutes before the news are released, and Lasso can pick that. Okay? And that's the interesting part of the paper. I think the author should have explored this more, but I think this is quite an interesting result. Somehow Lasso is uncovering some hidden information. That's where like machine learning kicks in. It's something that's not visible from by eyeballing the data, but somehow the statistical method, the statistical estimation is able to grasp this information. Okay, so I will end this block and I will end lecture 3 by making you think about that and what the issues that may be related, the right things and the wrong things in these applications. Please read the paper. But I think this is a very cool motivation why you are sitting in this class learning these methods, because there are a lot of things that these methods can do for us in empirical finance. Okay, yeah. So these are some kind of motivating questions. Think about that, all these questions, and we are going to discuss them during our live sessions. Thank you very much. Have a wonderful week.